So I'll start on 78. Now, what this is the rational polynomials do not have a common denominator. So this is kind of bringing all that stuff that we learned in together. So we're going to have to find the least common denominator, build the fraction, and then add the numerator, or combine the numerators. So 78 says 4 over x plus 5 over y. Now, first of all, what you want to do is make sure that your denominators are prime factored. Now, these are prime factored. Then you want to build the least common denominator. You look at your first denominator and take every prime factor from that one over to the least common denominator. You have to have an x go over. Then you look at your next one and you take all the prime factors there, and that involves y. Now you have to build your fraction so that you have the denominator be the least common denominator. So this denominator, when you look at the least common, lacks a y, so you have to put a y in it, and then you have to put a y in the numerator. Y over y is 1. You don't change the fraction, but your denominator is least common. You look at this denominator. It lacks an x, so you go x. You put an x in the numerator. So now you notice that every denominator is xy. So now what you do is you write xy as the denominator underneath a common line, and then you expand this. That's 4y. You bring this sign down, and then you bring this down. Now you look at that numerator and you say that there's nothing I can factor out, and nothing that I can cancel numerator and denominator, and that's going to be your answer then. Now if you look at 82, it says 1 over 2x minus 5 over 4x plus 7 over 6x. Now the first thing you want to do with each one of these denominators is a prime factor. This is prime factor. This one isn't. This has got to be a 2 squared x. This is not prime factored. It's 2 times 3x. Now you're ready to build the least common denominator. You look at your first prime factor denominator. There has to be a 2. There has to be an x. You look at your second one. That says 2 squared. You look up at your least common denominator. It only has a 2. So you have to have a second 2. You got to go 2 squared. There's an x here, an x up there, so you're good. Now you look at the third. There's got to be a 2. You look up here, there's 2 of them, so you're covered. Got to be a 3. You don't have a 3, so you have to add a 3. There's an x. So now this is your least common denominator. Now what you do is you take your least common denominator, look down here at this denominator, and say, what would I have to add to 2x to get it to be least common? Well, I'd have to have another 2, and I'd have to have a 3. So now in order to not change the fraction, you go 2 times 3 in the numerator. You look at this denominator, look at your least common. To make this denominator least common, you have to add a 3, right? And you put a 3 up here. Now this is least common. You look at this denominator. What do you lack? A 2 to make it 2 squared, right? You have to have a 2. You put a 2 up here. Now you notice that every one of your denominators is 2 squared 3x, right? So you put the 2 squared squared 3x as a least common. Then you take this, expand it, bring it down here as a 6. Take this sign, bring it down. Take these, expand it, bring it down. 15. The sign comes down, and the 7 times 2 plus 14. Now you simplify your numerator. Notice that that numerator is going to be a 5. And then it's 2 squared 3 times x. Now I'll accept it just this way, as the denominator prime factor. If you want to, you can go 5 over 12x. That makes you feel better. But this is fine. I really want you to leave that denominator in prime factored form until the very end. And as you go through and do them, you'll see that that's advantageous to do it that way. Let's do 90. Now as I do problems, if you want to see problems in between of what I'm doing, you just tell me and I'll do them. This is x minus 3 over 6x. Then it's plus x plus 4 over 8x. Now you want to prime factor your denominators. How is the 6x prime factor? 2 times 3 times x, right? How's the 8x prime factor? 2 cubed x. Now build your least common denominator. This says you have to have what? A 2 times 3 times x in it. This one says you have to have 2 cubed. You don't have it. So you have to write 2 cubed. Needs an x. You got an x. Here is your least common denominator. Now you have to build this denominator. The 2 times 3 times x right here. What do you lack? 2 squared. See, if you had a 2 squared, then you'd have a 2 cubed, right? 3x. So that's all you needed to put in there. What do you lack here? A 3, right? So you had a 3, you have the 3 over 3 does not change the fraction, but the 3 in the denominator makes it least common. So now every denominator has a 2 cubed, a 3, and an x. So you can just write it down there. Now then you expand this. Now, eventually you should be able to say that's 4 times x minus 3 and distribute it 4x minus 12. But I'll just do it this way. X minus 3. I'll expand the 2 squared into 4. Is that good enough? Is that too much to do at once? Bring the plus sign down. And then this next thing is x plus 4 times 3. Now I have to expand the numerator and bring together like terms. Distribute the 4, so that's 4x minus 12. And then this plus sign means I drop my brackets. Distribute the 3, plus 3x plus 12. And it's all over 2 cubed times 3 times x. Now you have to combine like terms in the numerator. Gives me 7x, and the 12s go away, right? Over 2 cubed times 3 times x. Now, notice that there's a common x over x, right? These right here. So they're multiplicative inverses, they go out. And my answer then is 7 over 2 cubed times 3. That's perfectly fine with me. If you want to go 7 over 24, you feel better about that, that's okay. Okay, any questions on that? I'll look at 96. It says x minus 10 over 4x squared plus x plus 1 over 2x. Now you want to prime factor your denominators. This is 2 squared x squared. And this one is prime. Least common denominator. It has to have a 2, I'm looking here. It has to have a 2 squared and an x squared. Look here, it says I have to have a 2x. Well, I got 2 squared x squared. I'm covered. Now then, you look at this denominator and compare it to least common, don't have to do anything. I look at this denominator, it looks least common. I have to have a 2 and an x. So it's 2x. Everyone good? Now each denominator has a 2 squared x squared in it, right? Now bring this term down, x minus 10. Bring this sign down, plus. And then this is actually x plus 1 times 2x. And I have to distribute that. Now you can skip this step by just combining these. Jump down to x minus 10 plus 2x squared plus 2x. You could actually go from this right down to here. Over 2 squared x squared. Now that numerator, I want to write it in descending order, leading term positive. And that's going to be 2x squared plus 3x minus 10. Now that numerator, what you want to do with that is you want to look at it and say, well, can it be factored? And if I factor it, can I cancel something in the denominator? But don't, if I could factor it, it don't look like anything to cancel. The question is, does it factor? And I don't, two numbers times itself gives you the minus 10 and 2. When you take their difference is 3. And I don't think there is anything. This is 1 and this is 1 and 2. This is 1 and 10 and 2 and 5. And I don't think there's any combination that's going to give you a difference of 3. So this right here is your answer. You can't reduce it down any further. That's the point. Notice 100, 98 and 100 have binomial terms in the denominator. I'll look at 100. It says 5 minus x minus 2 over x plus 1. Notice technically the denominator in 5 is 1, isn't it? Least common denominator. And both of these are prime factored. Well, 1 doesn't mean anything in least common denominator. But this says that x plus 1 must be in the denominator. Well, look, here it isn't there. So you need an x plus 1. And that means you need an x plus 1 over x plus 1. This one has the denominator. So now both denominators are x plus 1. Now this one says 5 times x plus 1. So that's 5x plus 5. This minus sign comes down. Whenever you do that, if there's a bracketed term, which there is, better bracket it to make sure you don't lose signs, right? So now that numerator is 5x plus 5 minus x plus 2 over x plus 1. Combine like terms in the numerator. It's 4x plus 7 over x plus 1. Now notice that does not, numerator doesn't factor, no reducing. So this is your answer to the problem. Do you see anything on the rest of that page that you want to see done? Anything? Notice 108 is the same as on the previous page, but 109, you got binomials in the denominator. So I'm going to do 110. And it says 2 over x minus 3 plus 5 over x minus 4. Now notice both those denominators are prime factored. So the least common denominator, you look at this denominator and it has to have a x minus 3. You look at this one, it has to have an x minus 4. So that's the denominator. Now you look at this denominator, you compare it to the least common, and it lacks a what? X minus 4. And you go x minus 4 over x minus 4. You look at this denominator, it lacks an x minus 3. So now both denominators have an x minus 3 times x minus 4 in it. So that's your least common. You can write it underneath that common line. Now then, this thing right here, going to be 2x minus 8, right? The plus sign comes down. And then this is 5x minus 15. That makes sense? Now your common denominator is x minus 3, x minus 4. And you combine like terms in that numerator. The 5x and 2x is 7x. Minus 8 and the minus 15 is what? Negative 23. Now that numerator does not factor. Nothing. And there's no common factors, numerator and denominator. So that's your answer right there. be 112. So it's 3 over y plus 6 minus 4 over y minus 3. Both of these denominators are prime factored, so the least common denominator is what? Y plus 6, y minus 3, right? Now you compare the least common with this denominator, and you're lacking a what? Y minus 3. So it's got to be y minus 3 minus over y minus 3. Compare it to this one, what are you lacking? Y plus 6. Y plus 6. Now what is your least common denominator? Y plus 6, y minus 3. Notice that both denominators have that in it. Now you multiply this out, and that's 3y minus 9. Minus. Do I have to bracket that? This minus came down. I better bracket that, right? 4y plus 24. So that I don't lose my signs. So now the denominator is the least common. And my numerator is 3y minus 9 minus 4y minus 24. Still y plus 6, y minus 3 in the denominator, but now simplifying. The 3y minus 4y is a minus y, right? Minus 9 minus 24 is a minus 33. Now, no matter what I do with that numerator, I cannot get something that will cancel in the denominator, right? Look at 120. Y over y squared minus 16 plus 1 over y plus 4. What about that first denominator? Is it prime factored? What is it, Alyssa? Okay, y minus 4, y plus 4, right? Because that's a difference of squares. Now, is this thing prime factored? Yeah, it is. So my least common denominator is going to be what? Y minus 4, y plus 4, right? Now, do I have to do anything with this denominator? It has y minus 4, y plus 4 in it. Do I have to do anything with this one? What do I have to do? You have to multiply it by y minus 4?
Actually, y minus 4.
What did I do? This is supposed to be y minus 4 here? Okay. It won't change the least common denominator, will it? It'll just change what we multiply it by. Y plus 4, right? Now both of them have a common denominator, right? Y minus 4, y plus 4. This y comes down, that plus sign comes down, and then this thing comes down. And we don't have to worry about brackets, right? So that numerator is going to be 2y plus 4 over y minus 4, y plus 4. Now they haven't, this is the answer. They haven't given us something, but I want to change this answer just to show you something. If that numerator had been 2y plus 8 over y minus 4 times y plus 4, what would you have done? You'd have factored the 2 out of here, right? And then what would you have done? You'd have canceled that with that. That's what you're looking for, that kind of stuff. You know, this is not the problem. They gave you this problem here. But that next step is what you would be looking for when you're trying to factor things. Okay, 124. This one says x over 1 minus x squared. Then it's a minus 1 plus x over 1 plus x. Okay, when you're trying to deal with this problem, what's the thing that you're going to have to try to factor denominators? What does the algorithm say that you always should do? Write your polynomial what? Descending order, leading term positive. Now, is the first denominator written in descending order, leading term positive? No. If you wrote it in descending order, it would be minus x squared plus 1. But now you don't have the leading term positive because it makes it hard to factor. So what would you do? You could factor out a minus 1 and make this x squared minus 1, right? Now, that minus 1, you could actually move it right up here and make the whole term negative, right? Isn't that right? That's the way you'd want to do it. Now then, you'd look at x squared minus 1. Is that factorable? It's a difference of squares, isn't it? X squared and 1 squared. So how does that factor? X plus 1, x minus 1. Now you got all your signs worked out and you got this prime factor. Now this denominator in the middle is actually 1. Now what would you want to do with this? Would you want to write it in descending order, leading term positive? So how would you write it? X plus 1. Now can you see, do you see common factor? I mean, it then becomes more obvious how to deal with the problem. So then your least common denominator in this problem, after you've modified it somewhat, is going to be x plus 1, x minus 1. Is that right? Now you look at this first one and you say, I do not have to change that at all. That is the least common denominator. But this one, what do you have to multiply by? You have to multiply it by x plus 1, x minus 1, right? Over x plus 1, x minus 1. What do you have to multiply this one by? X minus 1. So you go x minus 1 and then x minus 1. Now, notice, denominators are all 3 least common. So you draw a straight line across, you go, it's x plus 1, x minus 1. Now this first numerator, it's going to be what? A negative x. That second one is a negative, you bring that minus sign down. And then it's going to be the product of x plus 1, x minus 1. Then the third one, you bring this plus sign down, plus, and that's going to be x times x minus 1, right? Now we have to expand the numerator and simplify. Our denominator is still x plus 1, x minus 1. And the numerator is a minus x. Now I put a minus sign and put a bracket. When I multiply these two out, what is it? X squared minus 1. And this plus sign comes down. That's x squared minus x. Now I got to get my signs in my numerator. Squared away. Notice that starting out with the highest degree term, this one and this one cancel, right? What I have is a negative 2x plus 1 in the numerator. And I have x plus 1, x minus 1 in the denominator. And I cannot reduce that any further, so that's my answer. Let's look at 128. It says x plus 4, x squared minus x minus 42. Then it's plus 3 over 7 minus x. Now, is this one prime factor? Okay, Caleb says it's not. So if it's trinomial, not a special case, and if it factors, it's going to be x and x with the signs that are what? Plus and minus, opposite signs. What two numbers times itself is 42, whose difference is 1? 6 and 7. So which one is going to be where?
7 is going to be negative.
7 is going to be negative, and the 6 is going to be positive, right? Now what about this thing? You going to leave it like that?
No, we'll just switch it so it's in descending order. You switch signs.
Okay, you want to have it descending order, and you want to have the leading term positive. So what would that do? You could take the minus sign out, right? And then you could write this as x minus 7. Correct? Now then, you're ready to do least common denominator, which is what? X plus 6 times x plus 7, x minus 7. Now, this one is the least common denominator. What do you got to do here? X plus 6 over x plus 6. So now both of them are common denominators. X plus 6, x minus 7. And then this thing comes down, x plus 4, and then this, right? Negative 3x. Now I'm going to put a negative and go 3 times x plus 6, because I I tend to lose signs if I try to do too much at once. So then my numerator is going to be x plus 4. This changes the sign inside, so it's a minus 3x minus 18 over x plus 6, x minus 7. Now then combine like terms in the numerator, minus 2x, and then it's a minus, what, 14? X plus 6, x minus 4, minus 7. I don't know what I was doing there. What do you think? It would make you think that you might be able to factor it if you took a minus 2 out of that numerator. But if I've done it right, it still don't factor. This one's a plus right here, and this is a minus. Maybe I did a sign wrong, I don't know. But this one, if I had something that came out that way, I'd go back and re-look at my problem and make sure that that problem wasn't such that I could cancel x minus 7 or an x plus 7. You know, first of all, I'd be looking at this thing, make sure that that thing is a negative, not a plus. Because if that were a plus, then that would change it, right? And that's a negative. See, if that were a plus, then these signs would change around here. And then I would check and make sure that I did my signs correct when I did this multiplication, and so on. I'd go through the problem. It's too close to being able to cancel. Okay. So 1 over x plus 1 plus x over x minus 6 minus 5x minus 2 over x squared minus 5x minus 6. Now what's the first thing you're going to do? What's the first thing you're going to do? Check and make sure they're prime factored, right? Is that one prime factored? X plus 1? Gauge is a prime factor. This one? X plus 1. Are you shaking your head? Yes, it's prime factor. Okay. Is that one prime factor? X minus 6. Yes, it's prime factor. Is this one prime factor? That one's probably not, is it? It's a trinomial, descending order, leading term positive. It's not a special case. It would be x and x. The sign is going to be opposite. Few numbers times itself is 6, whose difference is 5. Okay, 1 and 6, isn't it? And which one has to be negative? The 6 has got to be negative. and the one's got to be positive. That's prime factor. Now, do you see the least common denominator? What is the least common denominator? Okay, x plus 1, then what else, Damon? X minus 6. So, what do you lack in there?
Perfect. X minus 6.
Okay, you're lacking the x minus 6. What are you lacking here?
X plus 1.
You're lacking the x plus 1. Are you lacking anything here?
No.
Nothing. So now you can write what? A least common denominator of x plus 1 times x minus 6, right? Now what are you going to put down here for that?
X minus 6.
X minus 6. What are you going to put down here?
X plus 2x squared.
Okay, you go plus x squared, right? Because this plus will not change anything, so it's plus x squared plus x. Now then, what are you going to do with this thing?
5x minus 2.
You either got to go minus 5x plus 2, run that minus sign through it, or else do a minus 5x minus 2, right? Whichever way you're going to go down here with that. If you want to take a chance that you'll get your signs right, it's a minus 5x plus 2, right? Now what are you ready to do?
Combine my terms.
Okay, you get a common denominator down here. And then you go descending order. What do you, looks to me like what, there's just an x squared? Then there's x. There's this x, that x, 2x, and a minus 5x is minus 3x. So I've got that, that, and then I got what? Minus 4. Did I do it right? Yeah. Now, can you factor that thing right there? How are you going to factor it? Pair of binomials? An x plus and an x minus, right? Two numbers times itself with 4, whose difference is 3. Okay, so where's the 1 and 4 go?
4 is going to be negative.
4 is negative and the 1 is positive. Now what?
You get rid of the x plus 1.
This x plus 1 and that x plus 1 go out, and you got x minus 4 over x minus 6. So that's the kind of thing you got to watch for, that last step, which okay. I'm going to leave it there, and we'll